Welcome to PreMath. In this video, we have got this green shaded equilateral triangle ABC, as you can see in this given diagram, such that it's all of side lengths AB, BC and AC are equal in length. And moreover, the area of this equilateral triangle ABC has been given to us as 3 times square root of 3 centimeter square. And now our task is to calculate the perimeter of this triangle ABC. Please don't forget to give a thumbs up and subscribe. And please keep in mind that this figure may not be 100% true to the scale. Let's go ahead and get started. And in this video, I am going to share with you with 2 different approaches. So therefore, please watch the video till the very end. And here's our very first method. And now let's focus on this triangle ABC. We know this is an equilateral triangle. So therefore, all of its interior angles are going to be congruent as well. And they are going to be 60 degrees each. And in this next step, I have dropped this perpendicular AD on this side BC, as you can see. And since we are dealing with this equilateral triangle, so therefore, this perpendicular AD is going to be not only the median, but also the angle bisector as well. In other words, this angle has got to be 30 degrees, and likewise, this other angle is going to be 30 degrees as well. And furthermore, this segment CD is going to be equal to this segment BD. And now let's focus on this triangle ADC. And we can see this is our special 30, 60, 90 degrees triangle. And here I have copied down this 30, 60, 90 special triangle over here. And here we can see 30 degrees is our smallest angle, whereas this 90 degrees is our largest angle. So no wonder this side opposite to this smallest angle is going to be our smallest leg. And the side opposite to this largest angle is going to be our longest leg. And this longest leg is also called the hypotenuse. In such kind of special 30, 60, 90 triangle, the longest leg is always twice the smallest leg. In other words, if the smallest leg is 1 unit, then the longest leg is going to be 2. And this third leg has got to be the square root of 3. And in general, if the smallest leg is lowercase a, then this longest leg has got to be 2 times a, and this third leg has got to be a times square root of 3. So therefore, if we focus on this 30, 60, 90 special triangle, and this side CD, which is our smallest leg, if I label this one as X, then this longest leg, the hypotenuse, is going to be 2 times X, and this third leg has got to be X times the square root of 3. And now let's make an observation once again. We know this segment CD equal to this segment BD. If this is X, then this BD segment has got to be X as well. So therefore, this whole side BC is going to be 2 times X. And now let's focus on this whole big triangle ABC. And now let's recall the area of a triangle formula. Area is always equal to a half times the base times the height. And in our case, the base of this triangle ABC is 2x. The height is x times square root of 3. And the area of this triangle ABC has been given to us as 3 times square root of 3. So let's go ahead and fill in the blanks in this formula. So our area of the triangle is 3 times square root of 3 is going to be equal to a half times the base is 2x times the height is x times the square root of 3. And here we can see this 1 divided by 2 and 2 cancels out. And likewise, we can cancel out this square root of 3 and this square root of 3 as well. So therefore, we are ended up with x times x is going to give us x square equals to 3. And now we are going to undo this square by taking a square root on both sides. So therefore our x value turns out to be square root of 3 centimeter. And since our x value turns out to be square root of 3, so therefore this side AC is going to be 2 times x is going to give us 2 times, if we substitute x value, that is square root of 3. And since we are dealing with this equilateral triangle, so all these sides are going to be 2 times square root of 3 across the board. So thus the side length of this triangle turns out to be 2 times square root of 3. So therefore the perimeter of this triangle ABC is going to be the sum of all these 3 side lengths. So therefore the perimeter of this triangle ABC is going to be the sum of 3 side lengths, 2 times square root of 3 plus likewise 2 times square root of 3 plus 2 times square root of 3. And if we add them, that is going to give us 6 times square root of 3 centimeter. So thus the perimeter of this triangle turns out to be 6 times square root of 3 centimeter by using the very first method. And now I am going to share with you the second method, and we will be using the Heron's formula to calculate the perimeter of this triangle ABC. And here's our Heron's formula. Area of the triangle is always equal to the square root of s times s minus a times s minus b times s minus c, where s is always equal to a plus b plus c all over 2, and s is also called the semi-perimeter. And now since we are dealing with this equilateral triangle, if I label this side length of the triangle as 2 times x, then this side is going to be 2 times x and 2 times x as well. And if I label this side as lowercase a, this side lowercase b, and this side lowercase c, then our s value is going to be equal to 2x plus likewise 2x plus 2x all over 2. So therefore our s value turns out to be simply 3 times x. And here's our Heron's formula. Let's go ahead and fill in the blanks in this formula. We know the area of this triangle has been given to us as 3 times square root of 3 centimeter square. So I'm going to substitute this value 3 times square root of 3 over here. And here for this s value, I'm going to substitute it with 3x, and then this s value is going to be 3x minus our a value is 2x, so I'm going to put down 2x over here. Likewise for this s value is 3x minus b value is 2x, and finally s value is 3x minus c value is 2x, as you can see in this next step. And now we can see 3x minus 2x is going to give us x. Likewise this is going to give us x, and this is going to be x as well, as you can see in this next step. And now we can see x times x times x and times x is going to give us x power 4. And we know the square root of x power 4 is simply x square. So therefore we can write this thing as 3 times square root of 3 turns out to be equal to x square times the square root of 3. And here we can see this square root of 3 and square root of 3, they are gone. So therefore our x square value turns out to be 3. And I'm going to undo this square by taking a square root on both sides. So therefore our x value turns out to be square root of 3. And if we substitute that value x over here, then this side length is going to be 2 times square root of 3. And since we are dealing with this equilateral triangle, so all these side lengths are going to be 2 times square root of 3 across the board. So thus the side length of this triangle turns out to be 2 times square root of 3. So therefore the perimeter of this triangle is going to be the sum of all these side lengths, 2 times square root of 3 plus 2 times square root of 3 plus 2 times square root of 3 as well. And if we add all these numbers, that's going to give us 6 times square root of 3. So thus the perimeter of this triangle turns out to be 6 times square root of 3 centimeter by using the Heron's formula. Thanks for watching, and please don't forget to subscribe to my channel for more exciting videos. Bye.